Hello. This is a video to go along with my other video about making a serial tracker device using Arduino. This is the code overview video. If you want to go watch the full video before you watch this, that link will be in the description. This is just going to be sort of an impromptu walkthrough. Yeah, let's get started. So what I have over here, this is what you will get if you download the repository from GitLab, and that will also be linked in the description. In there, you'll see a couple of things. These are step files, which are 3D model files for printing the various pieces you'll need if you want to follow along with the project. This README is just a README. And then these individual folders are actually the code that you're going to want to read through. So let's start with the sender receiver example. This comes up in the beginning of the video. Essentially, you upload this code to two different ESPs, and they're able to communicate with each other. So the two things we need are this ESP8266 Wi-Fi module, as well as this ESP Now module. I'll link another video that goes in depth about ESP Now and what it is, but basically it's quick and easy communication between two ESPs. So once we have those in, this you're going to need to get from, and I'll actually talk about that now, this MAC address reader sketch. So this one, it doesn't really use Wi-Fi, but it uses it to get the MAC address. So essentially we include this, and then in the setup, we set up a serial monitor, and we get the MAC address of a particular device. So you plug in an ESP8266, you upload this sketch, and you'll get the MAC address out. And you fill this section here in with whatever MAC address you get. So let's say you have a device A and a device B, and you put the MAC address for device B in here for the code for device A, and you put the MAC address for A in here when you upload the code to B. So that's what happens there. This is a callback function, so essentially when one sends data to the other, this function is going to be called. You get the MAC address and you get the length of the data. I'm not using either here because I'm just sending one number essentially. So if you know anything about pointers, we get a pointer to the data here, and we dereference it into a number. This is always going to be 0 or 1. As you'll see later, it's coming from a digital read. And basically we have an LED hooked up to pin D1, and we just write, if we write a 0 there, then it pulls it low and the light turns off, and if we write a 1 there, it pulls it high and the light turns on. We have a serial monitor here that gets set up just for debugging. It's not really necessary. And then here's the two pins that we set up. D7 is an input, D1 is an output. And so basically we're checking 7 and we're sending that data to our other ESP and we're displaying on 1. This Wi-Fi mode doesn't really matter because ESP Now overwrites that. Here we start the ESP Now. And if it doesn't work, then we can print out a message so we know. Here we set our role. There's a couple of different roles. There's the combo role, which is what we want right now because it's making it both the sender and the receiver. But if we look, we can see that thought I had autocomplete on, but I guess I do not. There's some other roles, and you'll see those in the example I linked in the description, but you can have a sender that's only a sender, a receiver that's only a receiver, or, like I said in this case, it's a combo, so it can both send and receive. This is where we actually register that callback function we were talking about before, so that when we receive data, it always goes here. And then this is how we actually register the other device we're sending our data to. So we have that receiver address from above. We're saying that the other device is going to be in a combo role. And then these things right here are not really important. Basically, this is for like encrypting our traffic if we wanted to. And this one is kind of how you can go on different channels. But again, we don't really care about that. Here we're going to have our data, which is just coming from a digital read of that pin. Like I said, it'll be a 0 or a 1. And then we're going to send that data to the receiver address. We give a pointer to our data. And then this is how many uint8s basically are in this pointer. So since we're only sending 1, it's 1. So that's that. We talked about the MAC. And then, so let me talk about the sender code, and then I'll talk about the receiver code, and then that'll be everything here. The sender sends information. So we set up these two things as before. I made this enum just for ease of read of our code in the future. Basically, we can have 3 states, full, half full, and empty. We have a tracker to keep track of our current status, and it starts always as empty. Here, again, we're going to fill in the MAC address for the device we're sending our data to. So you'd fill that in with whatever MAC address you have. This is another callback. This is for a data sent callback. So essentially we get some information about whether our delivery of our message was successful or not. And this is just for debugging. It's not really going to have any effect when we have the device actually out in the real world. So here we look. So we again just started the serial monitor for debugging. We put these 2 pins to input and these 2 pins to output, and I'll talk about that a little bit more. Basically, the reason that we have some output pins and some input pins, we really only care about input, but we're going to pull these pins low to save on power, and I'll explain that when we get down a little bit further. Then this is the same ESP now starting stuff. So this is what I was talking about. So by default, when we start these pins up, they're going to be high. And what that basically means is that we are going to have our ground for our sensors plugged into these. And so they're going to not be active until we pull these low. And that basically just saves some electricity because this is a battery-powered device. And so when we pull them low, it activates them. Then we can actually check our visual sensors. And we check by reading D7. It's going to be 0 or 1. And then we read D6, and it's going to be 0 or 1. So if both of them are full, then that means that, or both of them are 1, that means we're going to get a value of 2. And our quantity state is going to be full. If only one of them is 1, then when they're added together, we'll get 1. We'll get the half full. And if the case where we have none, we're going to get 0, and our quantity state is empty. So then once we've checked the sensors, we don't want to keep powering them, so we pull these pins high, and then that stops them from using any more electricity for the remainder of the code as we're running through it. Again, we have a debug here, and this is where we're actually setting up our roles. So here you see we have this controller role, which basically means it's going to be sending data. We register our callback for when we send the data, and then we register our peer, and you can see that's going to be the slave role. It's going to be accepting the data. Then we send our data out here, and we just cast that to a uint8. And then we do one more debug, and then we sleep for 30 seconds. And essentially what that's going to do is just put the device to sleep. And then after 30 seconds, it's going to restart the device, and we're going to start back at the top of this setup code. And basically that just uses less electricity. And then the last thing we'll talk about here is the receiver code, which is actually going to receive the information from here. And so again, starting here. Here, when we receive our data, if we're getting a 0 from the sender, then this is going to be the red LED. We pull it high, put the other 2 low. If we get 1, yellow LED high, other 2 low. And then if we get a 2, green LED high, other 2 low. And then here, pretty simple, just setting up the debugging serial, walking through all this. We do our pin mode to output. We set ourselves as the slave, and then we say we want to receive the data. And everything basically just happens here. We're just receiving because we set up the we don't have to say who we're receiving from because we say who we're sending to here, essentially, in our sender code. So our receiver code doesn't have to worry about it. And that's everything. Yeah. If you want to see the device in action, you can go check out my other video. leave any questions you might have in the comments, and I hope that this is helpful to someone.